Friction. When we first discussed Newton's first law, the concept of friction as a force that opposes motion was introduced without any details or even a discussion. So now it's time to do that. So look at this box to the right. You're pulling it with an applied force. Is it harder to get the box moving or to keep it moving? And what happens if you increase the mass of the box? And what happens if you pull the box over ice or sandpaper? So you probably found it was harder to get the box moving, and once moving, it required less force to keep it moving. And the more mass of the box, the more force was required to start it moving and keep it moving. And it's much easier to pull a box over an icy surface versus over sandpaper. Less of a force is needed. So the friction force appears to depend on whether or not the object was at rest or moving, its mass, and the surface it's moving on. So we'll first address the issue of the difference in applied force required to overcome the friction of a stationary object and a moving object by distinguishing between two types of friction, static and kinetic. Static friction force is a force that works to prevent the motion of a stationary object, whereas kinetic friction force is the force that acts to oppose the motion of a moving object. In both static and kinetic friction, it is harder to move a more massive object, so there's a dependence on the normal force, the force that the surface is exerting on the stationary or moving object. You could also think of this as if you're trying to rub your hands together. If you press your hands really hard together, you feel more friction than if they're just lightly pressed together. Also, both types of friction depend on the type of material that the object and the surface are made of. So this is represented by the coefficient of static friction and the coefficient of kinetic friction. These coefficients have been measured for many materials. The coefficient is represented by the letter mu, pronounced mu. And we put a K for kinetic friction and an S for static friction. Two things to note about friction. The forces are always parallel to the surface exerting them, and friction is always directed opposite to the direction that the object is moving. And it has a magnitude. Force of friction, kinetic friction, Fk, equals mu times Fn. Mu represents how rough or smooth the surfaces are, and the normal force represents how much those two surfaces are pushed together. The equation for static friction force is almost the same as the equation for a kinetic friction force, except that it has a less than or equal to sign in it. What do you think the significance is of that inequality? If there were no inequality, there would always be a force acting on the object, even if that object was just sitting on a table. And so what would that look like? It would look like there was a force to the left, and it was the force of static friction that was making an object accelerate. That just doesn't make any sense. So when an object is not subject to any applied force, there's no friction force acting on it. And as an external force is applied, the force of static friction will increase to a maximum value of mu s Fn. And once it reaches that and surpasses that maximum value, the object will move and kinetic friction will take over. So in other words, if we have an object sitting on a floor, if there's no applied force on it, there's no force of friction. If we have a small force applied, then we have a small force of static friction. They would be equal, this object would not be moving. As that force applied increases, so does the force of static friction, until it reaches a point where static friction is no longer great enough and it changes to kinetic friction. The maximum static friction force is greater than the kinetic friction force. Another way to say this is that the coefficient of static friction is greater than the coefficient of kinetic friction. So knowing this, what happens at the point when the applied force is greater than the maximum static friction force? You've probably experienced this if you've ever moved a couch or some other heavy object across a room. So assume you start pushing this object with a small force and nothing happens. So you increase your force and increase your force until that applied force becomes greater than the maximum static friction force. Then the object moves, and the smaller kinetic friction force is opposing your applied force. So the opposing friction force decreases rapidly, and you're still pushing with the same applied force. So that couch you're pushing accelerates, you're not ready for it, and you might fall over.